In this presentation, we are going to look at statistical analysis with R. This is an introduction to R for actuarial students. This corresponds to the CS1B curriculum, and that comprises an introduction to R programming, fundamentals of statistical analysis, probability distributions, and so forth. This corresponds to question 2 of this playlist, which is about correlation analysis. And just as a quick remark, the exam is on the basis of base R, so just the fundamental installation of R. Now, a student is performing a study to understand the correlation of temperature amongst different days of the week. Temperature on weekdays is recorded for 15 weeks in a file called TemperatureData.csv. Okay, so that's set up in my working directory. Okay, you should be able to find it there if you follow the links. Just go to the page and download it there if you want to play along. Generate the following correlation matrices. Okay, the Pearson correlation matrix, the Kendall's rank correlation matrix, also known as Kendall's tau, and the Spearman rank correlation matrix. Comment on the outcomes of the results in parts 1 to 3. Now, this is actually straightforward enough. Okay, so first off, I'm going to import my data set into R. I'm just going to call it capital D data, not lowercase data, because that's D data. That's a reserved word, but capital data. And what I'm going to do is calculate the correlation matrix of the data, okay, using the COR command. And just as a quick remark, the data set is entirely numeric, okay. So if there are any non-numeric variables in the data set, they have to be removed. So this will only work for an entirely numeric input. Okay. There I specify method equals Pearson. So this is the Pearson correlation coefficient. Now it seems that there's quite a lot of positive results there. That's good. Now I'm going to sort of complement that later on with a couple of additional remarks. But that is the first part of the question asked. The second part is asking us for Kendall's tau, Kendall's rank correlation coefficient. We do it the same way. The only difference really is here we asked for Pearson, method equals Pearson, and in this case Kendall. Okay. And finally Spearman, same again. Just type in Spearman there into the method. Okay, so that's the first exercise done, those 3 parts. The outcome of the Pearson method is based on the values of the data, whereas the Kendall and Spearman correlation matrices are based on the rank of the data sets in the value. Okay, so it's a sort of, one is a parametric analysis, it sort of works on the basis of assumptions about the data, whereas the other one is non-parametric and really is based on relative ranks and so on. Diagonals in each matrix represent the correlation of the temperature with respect to the individual days. For example, Monday to Monday. So the correlation matrices along the diagonals is 1 because they always have to be 1. Correlation, a variable's correlation with itself is always 1. Okay. Pearson shows strong positive correlation between the temperatures between Monday, Tuesday, Wednesday, and Friday. And Kendall and Spearman show lesser positive results as compared to Spearman's result. Now it's a short question, so really that's not a whole lot to it in terms of what we want to do. It's a very short, quick question. So that's the whole thing done. What I'm going to do though, just to finish off, is just show a visual complement. And this is core plot. And there's a couple of these different R packages that you can use to complement your analysis. So I'm going to just sort of complement what we've done there with looking at this package called core plot. Now essentially the input is the correlation matrix, okay? Correlation matrix. And essentially we provide that correlation matrix as a input to this command core plot, which is the same name as the package, okay? The command and the package have the same name. So it's core plot command in the core plot or package. So that's what we would get there when we run that. Now I think that's a very nice visual complement to the matrices we've just seen previously. Now this only works on the basis of Pearson correlation coefficient, and maybe it's possible to look at Kendall, tau, and Spearman as well, but we'll just sort of not be too worrying about that right now. You can also get a number rather than like here we have a sort of a circle that demonstrates the strength of the relationship and the depth of it as well. So positive there along that axis, the diagonal, okay, I should say. Very weaker correlation here between Monday and Wednesday, you know. Anyway, it's a little bit hard to read. Partly the problem there is that there's so much. The correlation matrices are fairly consistent with each other. Okay, you can actually do a complement to that called method equals number, which actually provides another matrix, another grid here, but rather than the spheres, we just actually have the actual numbers there, and they're color coded, and the color strength corresponds to this gradient here. Okay. Let's have a look at a different package. This is the punting package in the faraway, the punting data set in the faraway R package. Okay, just to sort of shake things up a bit there. That's the circles and the numbers. Okay, just swapped out the name of the data sets there, and so just applying it to a different data set. This is empty cars. Here it is a bit more variety in terms of negative and positive relationships. Okay, so you can sort of tell here that miles per gallon, the first one, and cylinder have a strong negative relationship. In fact, miles per gallon has a strong negative relationship with cylinder, displacement, and horsepower. The second, third, and fourth variable. Okay, whereas it has a relatively strong positive correlation with DRAT. I'll let you play with that, or play around with that. In case you're not familiar with it, this is an inbuilt data set in R called empty cars. If you type that into your command line in R, it brings up the data set. So you could try it out and see if you can get something like this. Okay, we'll leave it there. There's the numeric one as well, the numerical complement to that. Okay, we'll leave it there.